777,777,888,889. So I guess if you want to split that up, 277,777,778,888,899. This is a record-breaking number when it comes to the multiplication persistence of a number. So we'll do a smaller one just to get a handle on it. Would you like to give me a small, I don't know, like 3 or 4 digit number? What would you like, Brady? I always regret asking you this.
5428.
Right, so the first thing we do is we multiply all the digits together. So 5 and 2 is going to give us 10. 4 and 8 is going to give us 32. So it's going to be 320. And then we continue. We multiply all the digits together. Oh, there's a 0. So 0. So you made it 2 steps before we hit a 1-digit number. And if we have any 1-digit number, you can't multiply the digits anymore and you stop. So the question is...
I'm disappointed.
Yeah?
Can I have another try?
Do you want another go?
Yeah.
Let's try it. It's not called persistence for nothing. What would you like? See, where you went wrong, Brady, is a 5 and a 2 spells doom, because that's going to chuck a 0 on the end straight away. 3, 2, nice, you're going for primes. Look at you, okay. Let's see how that goes. So that's 6 sevens, which is 42. Someone will correct me if I'm wrong. 4 times 2 is going to give us 8, and then we're stuck with 8. 2 steps. At home, if you want, try and pick a number. See if you can beat Brady's current record of 2. So, how long do you reckon this one goes for?
Your big number.
Our big number. What do you think we're going to get out of that one? Have a guess. What do you reckon?
Because you've already told me it's a record holder.
It's a record.
But because you're willing to do it for me now, makes me think it's not crazy big.
When have I shied away from a crazy big calculation?
So I'm going to go for something surprisingly small.
Yeah,
I'm going to go for like 10.
10? Getting my calculator out. So, 2 times 7 equals, so that's 1 7, 2 4, 9 9 6 times 6 times 2. Whew. Okay, so now we're down to 4 times 3 times 8. What's very exciting about this is I've never actually checked this. Right, this is the first time I've actually, and now I'm feeling a little nervous. I'm like,
that's the level of preparation you get on number file.
How much prep I put into these videos. Brady is like, so what numbers are you into currently? I'm like, I'm kind of interested in this one. 2 7 times 6 times 8. 54. 5 times 4 is 20 is 0. 1 2 3 4 5 6 7 8 9 10 11. Oh, 11, and that's the correct answer. Thank goodness. It has a persistence of 11, which is the current world record for multiplication persistence of a number. Other numbers equal the record, but this is the shortest number with the biggest currently known persistence, and so that is the current champion.
Hang on, so you're with no limit on the number of digits?
Nah, knock yourself out. As many digits as you want. And often in these videos I say, I went away and I programmed a thing, and then I calculated it and I found this or I found that. I have not programmed this yet, because as you may have noticed, a little underprepared today. I haven't coded it up, but should we do it live? Do you want me to?
Let's do it.
Because I always say I code something and I find them. So
So funny story, last week
find it. I'll get my laptop. Keyboard stopped working and the trackpad on my laptop, which was a bit awkward. Okay, so first things first, we're going to set something going which is going to do this process over and over and over again, but we want it to stop once it gets to a thing which is only 1. Okay, so this is going to take some number, and the first thing we're going to say is if the length of the number of digits, so the string of n. So the great thing about n is it's normally a number. When we care about digits, I'm going to turn it into a string. So that goes from being like a number represented in binary or whatever base to just being the base 10 digits in a string. And if the length of that string equals 1, then we're done, right? We're at the very end of the thing, right? So let's, at that point, print whatever n is and then finish. So return, I don't know, like done. All right, that's just going to tell it, you know, your job here is done. Okay, otherwise, we need to multiply together all the digits. Digits equals, let's do it as a list, I for I, in the string version of the number, right? So it's turning it into a string of digits, and then it's taking out each one individually. Oh, but we want them as numbers. So let's turn them back into numbers. So bizarrely, I'm turning it into digits as a string, then taking out each one separately, then turning them back into numbers, right? Which is kind of, because this is a base 10 thing. One of the sad things about stuff like this is it's base specific. So now we've got all the digits for J. I'm just using J as the placeholder in digits. So now we want to multiply them all together. Oh, okay, you know what, let's have current result. Result equals 1 to start with, and then each time result equals result multiplied by that digit. And you can do times equals, just means make it equal to this times J. Oops. J. Okay. I think this is where we can cheat. And that's going to give us a new result. I haven't, but then we've got to repeat haven't tried coding this before, so I don't know if this is going to work. I'm going to try and get recursive and then put that new result into the same function. So if it's one long, it'll stop. Otherwise, it'll multiply all the digits together and then put it back into the beginning. And it will keep repeating through this process. And you know what? Let's make it print the result each time. So we get to see them all as it loops through. And then when it hits here, it'll stop and say done. Okay. That can't go wrong. Let's find out. I really should have checked this in advance. Okay, copy. I'm just going to fire up terminal. Okay, so what I'm actually going to do, this is the laziest way to run something, literally paste it into terminal. Let's do the persistence of 3, 2, 7, which is the second one you said. 42, 8, and then 8 forever, right? And so it's done 8 twice and then gone, we're out. Okay, I could fix the code to not get the last one twice. I just changed where the check is. So actually what I could have done is have another check in here. So I don't print the result and then print it again before stopping. Purpose, all right?
I could put the check
pass,
in,
it's fine. And then the very first one, let's just check the first one, just to make sure I haven't messed this up. 5, 4, 2, 8. It goes to 320, goes to 0, right? And now the ultimate test. Can it handle 2 6 7s, 6 8s, 2 9s? There we go, right? So, and that's so much quicker, right? So it's now spat out exactly these all the way down, and then it stops. Doesn't give us a number. Oh, do we want a number of steps at the end?
Number of steps. It would be a nice.
Okay. Brady will cut this out. I'll put it on the second channel. Of 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2. There, total steps 11. Okay, right, so now we can put a number in and instantly we get everything. We could no longer print every single step along the way. It's kind of fun to see. And we get the total number of steps. So, Brady.
Let's put a whopper in.
What would you like? You know, let's...
Put...
Should we just mash it for a while and see what we get?
No, because you
Do you want to be strategic? You're right, because we put in a 5.
Yeah. Just put in a bunch... Put in 15 nines.
15 nines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14... 15, which is just 9 to the 15.
No, put in another 10.
Oh, another 10 nines?
Yep.
Well, hang on. Let's just see if that one works. 2 steps.
Oh.
Because we got the 0 in the answer next time. But what I can do, when you're in terminal, if you just push up, you get the previous one. Chuck a few more 9s on the end. 2 steps. Oh. What if we put an 8 instead? 2 steps. Oh.
What about the string you used, like the current record holder,
yeah.
but put a 3 on the front?
Oh, I love it. Okay, so 3, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 9, 9. Ah, brilliant. I love your thinking. Ready? And 2 steps. This is harder than it looks. Right.
So it's zeros are zeros are a landmark.
Zeros. Boom. Hit a 0, you're out. This is Minesweeper, but for number searches.
Okay.
So this is what I would do. I would now play with this for a while. And it seems to be, whenever you put in some random string of numbers, and then boom, right? Because there was a 0 in the next one, it's gone. Would need to be more strategic.
What about all the digits of pi?
All of them. Done. I'll get cracking on that. 3, 1, 4, 1, 5, 9, 2, 6, I forgot. That's enough. 2. Wow. 11 seems a lot more impressive all of a sudden. No wonder it's the world record.
So does this mean, Matt, you could set up a program that would just put every number in one after another and just leave it, leave it for an hour or two?
So what we've done now is we've built the basics of checking. Next, we want to build something to do the search. So we could just get something to generate random numbers of a certain size, shove them in, and send us an email if it gets a good one. But the next step would be to be strategic about what numbers we're putting in. Because already you realized, don't put in a 5. You put in a 5, it's not going to work. So we could create a search which doesn't put in 5s, or doesn't put in any combination we know will definitely give us a 0. And actually we can get even smarter than that, because if we're looking for the smallest number that it works for, it doesn't matter what order the digits are in. So in fact, all the current record holders, the shortest number of digits for different persistence values, so there's a record holder for 10 and for 9 and so on, the digits are always in ascending order, because you want the smallest number with those digits. So in fact, you don't have to search for shuffled around versions, you just need that set of digits in that order. And then there's other things. So for example, this one here, we'll use your first one. You put in 5428, that's going to give you exactly the same result as, first of all, you could have put in 2458, which is smaller, but actually 2 times 4 is going to give you 8. So you could actually have just put in 588. That's going to give you exactly the same sequence as that, and it's smaller. So if all you care about are the smallest possible values for that sequence of persistence afterwards, multiplication persistence, then you never want to have a 2 and a 4. You never want to have 2 3s, because that could be a 9. You never want a 5 at all. In fact, you only ever end up with a few small numbers at the beginning, never more than 1 2, never more than 1 3, never more than 1 4, I think, and then all 7s, 8s, and 9s for the rest of it. So we could reduce our search space dramatically with a little bit of logic. The current search has gone as far as 233 digits. So if you do code it up, you've got to start searching from 233. It's not going to be smaller than that. We've already checked. And it's currently, the conjecture is, you will never beat 11. So if people want to have a go, I mean, I'm always one to give it a go. See if you can write some code. See if it does a clever search. And, it would be a major breakthrough if someone could find a number
Person
with
to
a
make that major
multiplication
breakthrough.
persistence of 12.
Certainly the sorts of people who crack the tough nuts are those who think outside the box, creative thinkers, people who don't follow the flock. And Brilliant wants to make you that type of person. Their courses, quizzes, puzzles, like the ones you see on the screen at the moment, they're carefully crafted to mould people into smarter thinkers. Not memorizers, not people who just know all the equations and how to pass a test. If you'd like to find out more about Brilliant, what they're making and how they might help you, go to brilliant.org/numberphile. There's free stuff on their site, but that /numberphile URL, that'll get you 20% off one of their premium memberships, and it'll also let them know you came from here.